In the name of Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make this channel a grand success. We are a family, a partner. Please share and subscribe our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunities into success stories. These success stories can be monetized into value addition in the world by large. Okay, today I'm going to discuss my lecture number 36. Oil and gas production, exploration, production, upstream, midstream, refining, petrochemicals, differentiated performance, enabling profit optimization process. Lecture number 36. Before my lecture, I read a Quranic verse. Qala Rabbi shrah li sadri wa yassir li amri wahlul uqdatam min lisani yafqahu qawli Allahumma Rabbi zidni ilma. O my Lord, open my chest and ease my task for me, and loose a knot from my tongue, that they may understand my sayings. Allahumma Rabbi zidni ilma, O Allah, advance me in my knowledge and true understanding. Please send me your input or feedback. I have provided my WhatsApp number and email address on my end of my presentation. Okay, oil and gas production. Oil and gas production, introduction, facilities and process, reservoir and wellhead management systems, upstream facility management systems, midstream facility management systems, refining facilities, petrochemicals. I have given a comprehensive detail on petrochemicals. Utility systems, we have already on utility system now. So unconventional and conventional resources and environment effects will be discussed on later stage. What's the ultimate goal? Shaping the clean and sustainable global energy delivery. Plan to deliver a more than 300 lectures next couple of years. Okay, oil and gas production, the utility system, lecture number 36. Today we have planned to discuss asset optimization and maintenance support, information management systems, power generation, distribution, and drives. Okay, key takeaway points, lecture number 36. Asset optimization and maintenance, IMS, integrated management systems, power generation and distribution systems. Okay, this is my first slide, asset optimization and maintenance support. An asset optimization system reduces costly production disruptions by enabling predictive maintenance. It records the maintenance history of an asset and identifies potential problems to avoid unscheduled shutdown. Maximums uptime and operate closer to plant production prognosis. This functionality supports maintenance workflow as the AO, asset optimization system, communicates with the maintenance system, often denoted as a computerized maintenance management system. It's also known as a CMM. Okay, this is my CMM schematics. If we can see here, this is my messenger to receive the response here. Here is the asset condition document. So this is my CMM, computerized management maintenance system. And this is my maintenance system strategy. First, create work orders, work order history, maintenance statistics, and preventive maintenance. Okay, then it's linked with the asset monitoring systems. So the right side, the service stop, and this is the operator response. And then over here, diagnosis and status document. So over here, that is also demonstrate heat exchangers and wells operation, and what is the ultimate goal to achieve maximum the utilization of plant asset over their life cycle. Okay, the condition monitoring includes both structural monitoring and condition monitoring for process equipment such as wells and rotating machinery. For structural monitoring, the devices are corrosion meters, essentially plates that corroded so that the corrosion may be metered, tension forces meters, and a free swinging strings. These statistics are logged to center structure conditions monitoring systems to show that the forces are acting against the installation and the effect those forces are having. Condition monitoring of machinery is generally used for the large rotating apparatus such as turbines, compressors, generators, and large pumps. Input devices are vibration meters, temperatures, bearing exhaust gases, etc., as well as the number of start-stops, running time, lubrication intervals, and overcurrent trips, costs, etc. For other process equipment such as valves, the system can register closing time, flow, and torque. A valve that exhibits negative trends in closing time for torque can be diagnosed. The maintenance trigger is the mechanism whereby the field devices or equipment monitor resident information in the form of digital status signal or other form, or other numerical or computed variable are interpreted to trigger a maintenance request. A work order procedure is then automatically initiated in the CMM computer's maintenance management system. Maintenance support functionality will plan a maintenance based on the input from condition monitoring systems and a predict maintenance plan. This will allow the system to schedule a personnel for such tasks as lubrication or cleaning and a plan large tasks such as turbine, compressor, periodic maintenance, etc. A specific information management systems can be used to provide information about the operation and production of the facilities. This can be a separate system or an integral part of the control system or SCADA system. If we can see here in the workflow, this is my web portal. This is an enterprise historian link with the office network. This is my office networks. Link with the integrated object model. This is my data, historians, and applications here. So these are linked with DCS systems, monitoring system, safety, and subsystem. These are linked and talk to each other at different to prevent different incidents. Okay, oil and gas IMS functionality includes. First, what is included here? The oil and gas production reporting system. Second here, safety management system, maintenance management systems, and then operator supports, overall system integrations and externals, overhead historian data, including post-failure flight record data, etc. Okay, on the next slide, we will discuss some of the application provided by the IMS may be following. Okay, some of the application provided by any IMS systems. So first, it demonstrates here the drilling data acquisitions and drilling data logging. The second here, the electronic shift logbook, operator procedures, chemical injection management, chemical consumption management, then laboratory analysis registrations, alarm and incident overviews here. So the alarm statistics here. So the valve leakage test, transmitter surveillance, and then runtime monitoring system, and block log here, and a production plan. Okay. On my next slide, we will further discuss from production plan to cell statistics report. Okay, as I discussed earlier slides, these are additional application. The cell statistics report here, the subsea valve signatures, production overview and prognosis, valves verifications, emergency shutdown and process shutdown verification including shutdown analysis, data exports, data browser tools, historian data and current trend, well testing performance, and daily production report with metering data. And then over here, the volume in storage cells and consolidation of the produced source and dispatch volumes, and environment reports, polynomial allocations, that is oil, gas, water based on the well test results. Okay, so from my next slide, we'll discuss a training simulator. Okay, training simulator. Training simulators are used to provide operator training in realistic plant training environment. They use the actual control and safety application of the plant running on operator stations. Plant models simulate the feedback from the plant in real-time operations or in the fast or slow motions. Training simulator, sometimes it's emulator simulators application, include functions for backup and reload, including recreations of history informations and snapshots. Offset training facilities are often connected read-only the live plant to provide information from the real operation situation. Okay, power generation, distribution and drives. Power can be provided from a main powers, local gas turbines or diesel generators. Such large facilities have high power demands from 30 megawatt up to several hundred megawatt. There is a tendency to generate electric power centrally and use electric drives for large equipment rather than multiple gas turbines, as this decreases maintenance and increase uptime. The power generation system on large facilities, usually several gas turbines driving electric generators from 20 to 40 megawatt each. Exhaust heat is often needed in a main process. Okay, electric single line diagram. If we can see here, this is my main power generators, and this is my HV relays, and over here show a 33 kV switch board. Okay, next over here it's a 6 kV switchboard, and these demonstrate here the large drives. Okay, so the further it demonstrates further distributed over here, it is 400 voltage LV distributions here, and this is my emergency switchboard, LV switch gears, and this is connected with the MCC main control room. Okay. Voltage level for high, medium and low voltage distribution boards are 13 to 130 kV to 2 to 8 kV and 300 to 600 volt respectively. Power is generated and exchanged with mains or other facilities on HV distribution board. Relays are used for protection function. HV is transformed to MV switchboards to which a large consumers are connected. LV switchboards feed a mix of normal consumer, motor control centers, MCC, and variable speed drives for motor up to a few hundred kilowatt, not necessarily separate as we have discussed in my last slide. Okay. HV is transformed to MV switchboards to which a large consumers are connected. LV switchboards feed a mix of normal consumers, motor control centers, MCC, and variable speed drives for motors up to a few hundred kW. Not necessarily separately. A separate emergency power switchboards provides a power for critical equipment. As I've discussed in my earlier slide, it can be powered from local emergency generator if main power is lost. Computer system is fed from uninterrupted power system, UPS system, with batteries connected to the main or emergency switchboard. Okay, a power management system is used for control of electrical switch gears and equipment performance. Its function is to optimize electricity generations and usage and to prevent major disturbances and plant outages, blackout. The power management system includes HV, MV, and LV low voltage switchboards plus MCC and emergency generators. Such functions include prioritizations of loads, emergency load, shutting, closing down of the non-essential equipment, and restart of the generator's assets. When additional power to start, a big crude pump is required. Okay, power generation, distribution, and drives. Large rotating equipments and generators are driven by gas turbines or large drives. Gas turbines for oil and gas productions are generally modified aviation turbine in the 10 to 25 megawatt range. These require quite extensive maintenance and have a relatively low overall efficiency, 20 to 27%, depending on the applications. Also, while a turbine is relatively small and light, it will usually require large and heavy support equipment such as large gears or coolers, filters, exhaust units, and sound damping and lubrication system. Okay. Okay, therefore, use of large variable speed drives is becoming more common. For a pump on a subsea facility, this is the only options. For use on remote facilities, high voltage DC transmission and HV motors can be used from main facilities or power from shore. This avoids a local power generation at each facility and contributes to low manning or remote operations. Thank you very much. It was my last slide. And now we are going to conclude today's presentation. Okay, conclusion. What we discussed today, asset optimization, maintenance support, and its strategy. Information management systems and power generation, distribution, and drives. Oil and gas productions will be flaring and atmospheric ventilation. Thank you very much for your precious time. Okay, there are a few references here. Qatar Petroleum, Doha Qatar Oil and Gas Development Corporation Limited, Pakistan, OGDC, Pakistan, World Energy Outlook, US Geological Survey, US Department of Energy, Shell Berger, International Energy Agency, Wikipedia, Oklahoma State Oil Fact Sheets, so also Standard Norway. So the story of oil in Pennsylvania, a liquor gas encyclopedia, natural gas from wellhead to burner tip. Okay. Together, everyone achieve more. Please do not hesitate to send me your feedback inputs. I have provided my email address and watch number. Thank you very much for your precious time. Please stay at home, stay safe, inspired, and blessed.